90% of people buying AI PCs right now are making a decision based on outdated information, and AMD just changed the game completely. Lisa Su just stood on stage and showed the world something that Intel and Qualcomm weren't expecting this soon. A chip architecture so tuned for local AI that it doesn't just compete with NVIDIA on your laptop in certain workloads, it beats it. And the price point? That's the part nobody's talking about. In the next 10 minutes, you're going to know exactly what AMD's new AI PC lineup actually does, why Lisa Su's GPU strategy is genuinely different from what everyone else is selling, and how to figure out whether this hardware belongs in your workflow or not. No hype. Just the real breakdown. And at the end, I'll reveal the one specific technical detail buried in AMD's architecture announcement that most reviewers completely glossed over, and it changes how you should think about buying any AI PC in 2025. Stick around for that. Let's start with the hardware itself, because the numbers here are genuinely wild. AMD's Ryzen AI 300 series, the chips powering their new AI PCs, pack an NPU, that's a neural processing unit, rated at 50 TOPS. TOPS stands for tera operations per second, and it's the standard measurement for how fast a chip can crunch AI math. Microsoft's Copilot plus PC requirement sits at 40 TOPS. Apple's M4 chip hits around 38 TOPS on its neural engine. AMD's Ryzen AI 9HX 370 hits 50 TOPS on the NPU alone, before you even factor in what the GPU is doing alongside it. Now, TOPS isn't the only number that matters, and we'll get to why in a minute. But it does tell you something important. AMD isn't playing catch-up here. They shipped ahead of where the market expected them to be by at least one product generation. The chip uses AMD's Zen 5 CPU cores combined with RDNA 3.5 integrated graphics, and that NPU is built directly into the same silicon die. No separate chip. No thermal bottleneck from two pieces of silicon fighting over the same power budget. Everything is talking to everything else on one piece of silicon, which matters enormously for latency when you're running AI models locally. And speaking of the GPU, this is where Lisa Su's broader strategy clicks into place. Because AMD isn't just selling you a laptop chip. They're selling you an ecosystem. Lisa Su has spent the last 3 years quietly building what AMD calls ROCm, their open-source alternative to NVIDIA's CUDA platform. CUDA is the reason NVIDIA dominates AI training. Developers write their AI code in CUDA, it runs on NVIDIA hardware, and switching feels like moving house. AMD looked at that lock-in and built ROCm to be compatible with PyTorch and Hugging Face out of the box. Here's why that matters for you as an AI PC buyer. When you run a local AI model, something like Llama 3, Mistral 7B, or Stable Diffusion XL, the software needs to talk to your GPU efficiently. On an NVIDIA card, that pipeline is 20 years mature. On AMD's integrated RDNA graphics inside the Ryzen AI 300, ROCm now handles that pipeline. And in mid-2025, AMD's own benchmarks show Llama running Llama 3.18b at around 25 tokens per second on the Ryzen AI 9HX 370. That's fast enough for a real-time conversation interface. That's not a demo number. That's a working local AI assistant on a laptop. But here's where it gets interesting, because the laptop chip is only half of Lisa Su's GPU story. Quick note, if you're finding this useful, subscribing takes literally 2 seconds and it genuinely helps me keep making these deep dives instead of surface-level coverage. Now, back to AMD's GPU strategy. At CES 2025 and through their spring roadmap, AMD announced the Radeon RX 9070 and RX 9070 XT, their first RDNA 4 desktop GPUs. The RX 9070 XT launches at around $599. For context, NVIDIA's RTX 4070 Super, which is roughly comparable in rasterization performance, launched at $599 too. But the RX 9070 XT pulls ahead in AI inference tasks because of one specific hardware feature: 16GB of GDDR6 memory on a 256-bit bus. Why does VRAM matter for AI? Because every parameter of an AI model needs to live in GPU memory while it's running. A 7 billion parameter model in 4-bit quantization takes roughly 4 GB. A 13 billion parameter model needs about 8 GB. A 70 billion parameter model, the size that actually rivals GPT-4 quality in many benchmarks, needs around 40 GB. The more VRAM you have, the larger the model you can run without offloading to slower system RAM. At 16 gigs, the RX 9070 XT handles Llama 370B in 4-bit quantization comfortably. An RTX 4070 Super has 12 gigs. Do the math. Did you know that the single biggest bottleneck for running local AI in 2025 isn't processing speed, it's memory capacity? Most people obsess over clock speeds. The people actually running models obsess over VRAM. File that away. Now, ROCm support on RDNA 4 is what ties this all together. AMD has specifically optimized ROCm 6.2 for RDNA 4 architecture. Tools like LM Studio, which is the easiest way for non-coders to run local AI models, added AMD GPU support. Stable diffusion interfaces like Automatic 1111 and Comfy UI both run on AMD through ROCm. The software ecosystem gap between AMD and NVIDIA, which was a genuine deal-breaker 18 months ago, has closed dramatically. Let's talk about real-world AI PC use cases, because specs only mean something when they solve actual problems. Scenario 1, you're a content creator running Topaz Video AI to upscale footage. On the Ryzen AI 300 integrated graphics, processing time drops versus previous gen Intel integrated graphics by roughly 40%, according to early third-party testing on NotebookCheck's 2025 benchmarks. That's not a marginal gain. That's the difference between rendering overnight and rendering before lunch. Scenario 2, you're a developer using Continue.dev or Cursor with a local Codestral model. On the RX 9070 XT desktop, you're getting sub-second response times on code completion for a 7B model. That's a functional, private, offline GitHub Copilot replacement running entirely on your own machine, no subscription, no data leaving your network. Scenario 3, you work in an industry with strict data privacy, legal, healthcare, finance. You cannot send client documents to OpenAI servers. With an AMD Ryzen AI 300 laptop running Llama 3.18b locally through LM Studio, you can summarize contracts, draft responses, and analyze data with a frontier-class model, entirely air-gapped from the internet if needed. That use case alone justifies the hardware for thousands of professionals. Here's a pattern interrupt for you. AMD's biggest AI competitor in the laptop space right now isn't NVIDIA. It's Qualcomm's Snapdragon X Elite. Qualcomm hit 45 tops, has excellent battery life, and the MacBook-style ARM efficiency is genuinely impressive. But Snapdragon X Elite has a hard ceiling, 8GB of shared memory on most configurations, with 16 gigs as the expensive option. AMD's Ryzen AI 300 laptops pair the 50 tops NPU with up to 96GB of DDR5 system RAM, some of which gets allocated to the integrated GPU. That changes the ceiling for model size dramatically on a laptop. Now, the reveal I promised you at the start. The thing most reviewers didn't mention. AMD's Ryzen AI 300 uses what they're calling unified memory architecture with AI tiling. Here's what that actually means in plain English. Normally, your CPU, GPU, and NPU each have their own memory pool. Moving data between them costs time and power. AMD's implementation on the Ryzen AI 300 creates a shared memory fabric where all three processors can access the same pool without copying data across. So when you're running a multimodal AI task, say, processing an image with the NPU and then generating text with the GPU, the data doesn't travel. It's already there. The practical result, in multimodal AI workloads, AMD's architecture reduces latency by up to 30% compared to discrete NPU designs according to AMD's own technical white paper from January 2025. As AI models become more multimodal, and they will, that's the entire direction of the industry, this architecture advantage compounds. The reviewers who benchmarked single-task LLM speeds missed this entirely. You're not just buying today's AI PC. You're buying an architecture designed for where AI models are going in the next 2 years. So what do you actually do with all of this? First, if you're buying a laptop for AI work in 2025, put the Asus ROG Zephyrus G14, the Lenovo ThinkPad X1 Carbon with Ryzen AI 300, or the HP OmniBook Ultra on your shortlist, all ship with the Ryzen AI 9 HX370. Second, if you're building or upgrading a desktop for local AI, the RX 9070 XT at $599 is the best VRAM per dollar card available right now for models under 40 billion parameters. Third, download LM Studio today. It's free, it works on AMD through ROCm, and you can have Llama 3.18 be running on your own machine within 20 minutes. Fourth, if you're in a privacy-sensitive industry, document the local AI capability in your workflow. It's a genuine competitive advantage that most of your peers haven't discovered yet. Fifth, bookmark AMD's ROCm compatibility page. It updates monthly and the software support list is growing fast. AMD gave us something real here. Not a roadmap promise. Not a coming soon slide. Shipping hardware, shipping software support, and an architecture that's genuinely built for where AI is going, not just where it's been. Lisa Su played a long game with ROCm and it's paying off exactly when it matters most. The AI PC market is real, the local AI use cases are real, and for the first time in years, NVIDIA doesn't have a monopoly on the hardware that makes them work. If this video saved you time or gave you something actually useful, subscribe. I post every week and the next video is breaking down how to build the perfect local AI setup from scratch using AMD hardware, software stack, model selection, the whole thing, and it's coming next week. One question for you in the comments: are you running local AI models right now, or is that still something you're planning to try? Let me know, it helps me figure out exactly what to cover next.